This is a paper plane. I've added some practical functionalities to it using Geometry Node. The paper plane can move along the curve. You can adjust the number of paper planes. The flow speed parameter can change the speed of movement. Offset can adjust the offset of the paper plane on the curve. Random values can be used to change the size of the paper planes. Similarly, the size can be changed by adjusting the radius of the control points. Rotation also be achieved. The change speed switch can change the moving speed of the paper plane at both ends of the curve. Using this geometry node, you can also create something like these. Magical particles swirling around. Falling dust. Stylized smoke. Now I will show you the step-by-step process of creating this geometry node. Let's get started. This is the paper plane. Create a Bezier circle. Switch to the Geometry Node panel. Create a geometry node. The Curve to Points node evenly distributes a specified number of points along the curve. Create an instance on Points node to replace these points with the paper plane. Place the paper plane in a collection. This step is not necessary. You can also use this model directly. Connect the instance to the collection. Output the collection externally to be specified in the Modifiers panel. Look, the paper planes are distributed along this curve. Whether the collection is visible or not doesn't affect the normal functioning of the geometry node. Let's organize the nodes a little bit. Create a join geometry node to merge the curve and paper plane. Now, you can easily edit the shape of the curve in Curve Edit mode. Select these nodes, press Shift+P to group them, and press F2 to name the group. When there are many nodes, grouping helps with logical understanding. You need to enable the built-in Node Wrangler add-in to use grouping function. Now, let's create the function for the plane to move along the curve. Create a set position node here. Then, create a sample curve node. Connect position to position and input the curve into curves. At this point, you'll notice the paper plane has become 1. Open the statistics. In reality, there are 10 paper planes in this position, plus 1 from the collection, making a total of 11. I primarily use the factor node to control the movement of the paper planes. Factor represents the point's position on the curve. Output the count externally. Add a math node. Change it to divide. The index node represents the points number on the curve. Connect the total number of points to here. Use a wrap method, setting min and max values corresponding to the factor. Connect the value to the factor. This way, the paper planes are evenly distributed along the curve. The principle is, assuming this paper plane's number is 0, 0 divided by the total number of points 10 is 0, so its position on the curve is 0. The next paper plane's number is 1, 1 divided by the total number of points 10 is 0.1, so its position on the curve is 0.1. And so on for the rest. Now, let's make the paper plane move. Insert an add node in here. Connect this value to time. Now, the animated paper plane is moving. Add a multiply node to control the animation speed. Develop a good habit and group these nodes. Now, let's add control of control points to the paper plane. I created a circle on the side, generating mesh under bevel. In curve edit mode, you can change the mesh size using the control point's radius. Now, let's add the same function to change the size of the paper plane. Here, I use another set of points to control the paper plane's size. If you accidentally place nodes in a group, use Alt+P to remove it from the group. Create these two nodes and link them like this. These two nodes mean using point to affect certain properties of nearest. Here, add a scale instance node. Connect value to scale. And after adding a radius node to this value, you can control the nearby paper plane's size using the control point's radius. After enabling the animation, you'll notice that the scale change is stepped. This is because the number of points in this set is too few. Change it to 200, and the scale change becomes smooth. Now let's determine the loop length. At frame 250 on the timeline, the animation doesn't loop. I increased the frame rate to make the animation more detailed. This value controls the speed of the animation. Simply divide the frame rate by this value to get the minimum loop frame. Now the animation is looping. Control points not only change the scale but also control rotation. Next, add the same function to the curve of the paper plane. The shortcut for this is Ctrl+T. Create a rotate instances node here. Duplicate a sample index node and link it as before. Use the curve's tilt property to control rotation. And finally connect the value to rotation. At this point, notice that the rotation direction seems strange. We need to make it rotate along a specific axis. Create a separate XYZ and combine XYZ. Only affect the direction of a specific axis. The current effect still doesn't meet expectations. What I want is for the plane's heading to follow the direction of the curve. And the tilt property should also control the rotation of the plane along the direction of the curve. Although here the link gets the corresponding result. Add an align Euler to vector node. Use the curve's tangent direction to control the rotation of the paper plane. Leave x-axis for control point control. Here, only y and z-axis properties are needed. Now, the desired result is achieved. However, there is still a problem. When we change the shape of the curve, the rotation in this section looks odd. Let's solve this issue. Copy the align Euler to vector node. Fixing the z-axis and constraining the x-axis can solve this problem. Now, regardless of how we change the shape of the curve, the paper plane can smoothly fly along it. Next, let's group these parts. The main function of this node is now complete. Let's add some additional controls. Use the offset to control the paper plane's offset on the curve. Add a random value. Since we don't want the paper plane to offset along the curve's direction, set x to 0. Use a value to control them. Min only needs to be multiplied by -1. Add a combine xyz to change only the yz values. Apply the same operations to max. In addition to using control points to control the size of planes, I also hope to control the overall size of them. Scale can change the size of the paper plane. I also added a random value. For convenience, I outputted min and max externally and gave them names. Output offset externally as well. Finally, add speed variation to the paper plane. Here, I used a new curve to illustrate. Add this geometry node to this curve. Output the control of speed externally. At this position, add a square root node. Now you'll notice the plane has speed variation at one end of the curve. Adding a power node can change the position of this variation. I created a switch node to control whether this effect is enabled. Change it to the corresponding float value. By default, I want this effect to be off, so connect the value to true, and the uniform motion from before to false. This way, when you check the switch, this effect is enabled. Output the switch externally and give it a corresponding name. Output this value externally to easily control the speed variation position. At this point, all the node functionalities are complete. You can adjust the positions of various properties according to your preferences. Afterward, I organize the nodes, and you can take a screenshot for reference. The following are the setup processes for a few small examples at the beginning. Enjoy it. Hope this video can help you. Thank you for watching. See you next time.